Okay, folks, it's Sunday afternoon and we've got one more demonstration done, and finally we'll be able to figure out why doctors and nurses and hospitals measure blood pressure in units of in units of millimeters of mercury. It's because they use what is called a manometer. The manometer was invented over 400 years ago by Galileo's student Torricelli. They didn't have any way of creating a pressure gauge like this, but they did have mercury available, and they did know that a column of mercury, 29.92 inches high, 1 square inch in area, that column of mercury would weigh 14.7 pounds and would exert a pressure of 14.7 pounds here. So by using a container full of mercury and a tube, and the tube is sealed so that if a pressure is exerted on the container, the mercury will climb. And when the pressure would be such that the mercury got up to here, then the pressure on the outside of this container would be 14.7 pounds per square inch over and above atmospheric pressure. At any rate, this height of this column of mercury could be used to calculate the actual pressure in the body. So I've taken my blood pressure pump, my blood pressure cuff, and I've placed it around this plastic bottle that is filled not with mercury, so we have to use our imagination. This is filled with water and food coloring. And when I turn on the pump, I will squeeze the container just like I would squeeze my arm, and the pressure will build up and the column of mercury over on this side will rise. Right now, the bottom of the column of mercury is right here, and as I add the pressure, I will have an indication of how much pressure is on my arm, but it will not be in pounds per square inch, it will be in millimeters of mercury. Now, my blood pressure runs about 120 over 80. That means the highest blood pressure is 120 millimeters of mercury, and the lowest is 80. This is about 120 millimeters. So because this is water, the level of the water is going to rise extremely fast. But if it was mercury, when I got up to 120 millimeters on the indicator, the mercury would rise about 120 millimeters above its reference level here. So let's see how it works. I've got a chance of a leak in the back because I had to glue this tube into the can, but let's see if we can see the red liquid rise. Here we go. Okay, the pump is coming on. You can hear the pump. The pump is squeezing, and there it goes, there it goes, there it goes. I've got to stop it because the water is so light that it would squirt it right out of the top. But if that was mercury, it would have slowly come up, and when it came up to 120 millimeters, that would correspond to what is called my systolic pressure. Systolic is the high one, diastolic is the low one. So there's a process that they use when the system is connected to your arm, because they use a stethoscope. And when the pressure gets up high enough, the stethoscope can no longer hear the blood flowing. That's the systolic. Then they let the pressure off, and pretty soon you can hear the blood pulsing again. That's the diastolic. So there are two values of the pressure represented in millimeters of mercury. Again, it's not the actual pressure. We would have to do a calculation knowing that if the mercury came all the way to the top, the pressure on the container here would be 14.7 pounds per square inch, and then we could do a simple proportion or ratio to figure out what that is. Okay, let's do it one more time. Here we go. We turn on the pump. It's getting ready. There it goes. It's squeezing the cuff, and we can see our pressure is building up. Whoa, stop. Don't want to squirt it out of there. Now, wasn't that fun? And so if somebody asks you, what is your blood pressure and how do they measure it? Tell them they measure it in millimeters of mercury, and it's not actually a pressure, but it's a representation of your pressure. That's why they did this 300 or 400 years ago. They could make a mercury manometer. It's not a barometer, it's a manometer, and we'll get to the barometer later because that's used to measure atmospheric pressure, absolute atmospheric pressure. But this simply measures the pressure of the cuff that is squeezing on either your arm or on this container. I hope you like that. That's the last for today.